So, hey friends, this is me, Vishwas, and I'm the host of this webinar. A lot of times, KEDA has driven a lot of value in terms of scaling the right way. And there is a lot of things that goes on when the system has to really scale up to the extent that we require. And KEDA has been one of those form factors that we obviously look back and we always learn about. And here I'm with Nilesh, who is going to give you a lot of insights about how KEDA is going to make a lot of impact in your production every single day. Over to you, sir.
Hey Vishwas, thanks. Let me share my screen and let's get started from there. So today we are going to talk about distributed event-driven systems with KEDA, which stands for Kubernetes-based Event Driven Autoscaling. My name is Nilesh, and here is a brief summary of my public handles for all the socials that I use. I was currently I'm one of the Microsoft Azure MVP, and I also host the Azure Singapore user group. We have a YouTube channel as well. In case you are interested in some of the Azure topics, you can head over to our YouTube channel and you can find a lot of information related to Azure there. Apart from being a techie, I also like the game of cricket. So if you're interested in talking about cricket, IPL, upcoming World Cup, we can also discuss that. Brief history about myself. I was born and brought up in Goa. Some of you might have visited some of these places in Goa. Goa is distinct in its culture, architecture, because it was a Portuguese colony. And you find a lot of things, especially food and also people who are quite different from rest of India. So if you have not visited, I highly recommend that you visit these places when you visit Goa. Now, coming back to today's session, the agenda is we will look at what are the different options for us when we talk about scaling, and specifically about scaling in Kubernetes. Then we will look at the overview of KEDA, which is one of the open source project which allows us to do scaling. We will also have a look at a very small application which is called Tech Talks and which uses RabbitMQ as one of the message brokers. And then we will see how KEDA can help us in the auto-scaling part. And finally, we'll close down with the architecture of KEDA and we'll have some Q&A if time permits. Before I start, here are some of the prerequisites for this session. Because we are talking about Kubernetes and we are talking about auto-scaling and stuff like that, I assume that people know about these things like Docker, how to build self-contained applications with all their dependencies using Docker images. Bit about Kubernetes, how Kubernetes helps to orchestrate the containers, how it has things around self-healing, self-discovery. Then a knowledge of container registry. We'll be using Azure Container Registry, but you can also use things like the Docker Hub public registry or any other container registry for storing and retrieving the container images. And I will be using Azure Kubernetes Service or AKS, which is a managed offering on Microsoft Azure. So a bit of knowledge of how the managed Kubernetes works and things like how to integrate other Azure services like Active Directory, then Azure Container Registry, Azure Container Instances. This might be helpful. So let's get started by looking at what are the different options for scaling. When it comes to Kubernetes, there are 4 different ways in which we can scale. First one is the manual one, where operator or administrator goes and scales the Kubernetes objects. This might be useful when we know exactly when we have to scale. Let's take maybe a couple of examples. This is a long weekend in Singapore where we have Chinese New Year, and there are a lot of promotions and things like that happening during the Chinese New Year. It could be something similar what happens during, let's say, Cyber Monday or Black Friday, Christmas, New Year times. Anytime we know that there is a fixed interval for which we are expecting big rise in our workloads, or there will be quite a big load on our systems, we can go and do this manual scaling. The other one, it's like automated or semi-automated way in which we use one of the other options. It could be horizontal pod autoscaler or HPA, where based on the resources, we can let Kubernetes controllers or the schedulers itself scale the objects for us. The HPA works, or horizontal pod autoscaler works, on the basis of how much the consumption of RAM or memory is there, or CPU is consumed for a particular pod. And then we can define a range within which, if it exceeds, then the HPA will kick in and it will increase the number of instances. On the other side, there is the vertical pod autoscaler, where we keep the number of pods same, but we increase the resources that are allocated to the pod. So let's say initially we start with 500 MB of RAM and 2 CPUs given to a particular pod. As the workload increases and we realize that that particular resources that are allocated to that pod is not enough, then the vertical pod autoscaler can automatically add more resources. This is both the horizontal pod and vertical pod autoscalers are helpful when we have enough resources on our cluster. The last option, the cluster autoscaler, is where we have certain number of resources, but those resources itself are not good enough to support the scaling needs. So let's say we started with 50 pods and the horizontal pod autoscaler kicked in and the number of pods has increased to 100. In the next cycle, where it realizes that even more pods are required, it will go and try to add, let's say, another 50 pods. And there is not enough resources on the cluster itself. In that case, we can enable the cluster autoscaler, where the cluster itself can scale and it can add more resources. So let's have a quick look at one of these, which is the manual scaling, and see how it works. So I'm going to run a small command here on the command line. I'm using Windows Terminal, which is one of my favorite terminal for working with Kubernetes. And let's first say how many nodes we have. So if I use kubectl get nodes command, I have this AKS cluster created with 3 nodes, and we can see that all the 3 nodes are ready. This was created about 14 hours ago with 1.24.6 version of Kubernetes. With this, I know that I've deployed some things on this cluster. And if I do kubectl get deploy, it will tell me what are the deployments which are currently running. I have a RabbitMQ producer and consumer deployment running here. Now let's assume that I know that I have to scale the consumer. Currently, there is one instance or one replica of this deployment running. I can run a scale command here saying kubectl scale, and I can give the number of replicas. Currently, there is one replica for the consumer, and let's say I want to increase this to 3 replicas. And then I give the name of the deployment, which is RabbitMQ consumer deployment. So what I want to do is change this replicas from 1 to 3. So that was the manual mode. So as I said earlier, to demonstrate how we can use KEDA or how we can use scaling effectively on Kubernetes, I'm going to use a simple application, which is called as the Tech Talks application. Think of this as an application for managing technical events like Event Tribe or Meetup. And in this, I have 2 things. One is the producer, which is a configurable API where I can pass the number of messages which has to be generated, like how many events have to be generated. The producer creates those many number of events or those many number of messages and pushes it onto a RabbitMQ. And then there is the consumer, which will consume this. And these are decoupled using RabbitMQ as the broker in between. This is all built in .NET Core, the producer and the consumer. And I'm using the Docker version or Dockerized version of RabbitMQ. So everything what we see here is deployed on Azure Kubernetes Service or AKS. And some of the things that I use for deploying this application is everything that I'm talking now is available on GitHub. You can replicate this demo if you want in your own environment. I use manifest files for deploying my own applications services. Like I create deployment and I expose that using the Kubernetes service object, which is created using the Kubernetes manifest files. For the third-party apps that I'm using, which is RabbitMQ in this case, and as well as KEDA later, I use Helm chart. So Helm is a package manager for managing the artifacts for Kubernetes or applications for Kubernetes. Instead of running individual manifest files, I can use a pre-packaged application using a Helm chart, and that is what I do for deploying RabbitMQ. In order to visualize the state of the Kubernetes cluster, I've used Octant or Lens in the past, and for this demo, we will use Lens. I use kubectl to apply these changes and a bit of PowerShell scripts to automate them. And in order to generate the workload or to call the API, I don't have any UI here. So in order to generate that workload, I use a Postman or a REST client. So let's go and see how we can have a look at some of these resources. And that's where I want to bring in Octant and show what the current state of my Kubernetes cluster looks like. Okay, so this is how the Octant UI looks like, and it gives me a complete overview of what's running in my Kubernetes cluster. So when I go to the overview, I can see what all deployments are there, what all services are running, and all the other information. Like I have two deployments, RabbitMQ consumer, RabbitMQ producer, and this is currently running under the default namespace. There might be others running under the system, or I might have created other namespaces for RabbitMQ and others. In terms of the pods, we have one pod for RabbitMQ, one for the consumer, and one for producer. And we have other objects like the replica sets, stateful sets. So I can basically navigate using these different features and look at specific information related to the pods. I can look at the service discovery, load balancing, services which are running. All the state of my Kubernetes cluster, I can visualize easily using Octant. So instead of running the kubectl commands every now and then, this is quite helpful for me. So I have this service which is exposing my producer, and it has a public IP associated with this. And using this public IP, I'm going to generate the workload. So if you remember, I have one replica running. So let me go and use Visual Studio Code here to generate the workload. And I'm using a REST, which allows me to call that REST API or the API. So let me go and first start with generating 10,000 messages. I'm going to call this Tech Talks API endpoint with the generate method, and the number of messages is 10,000. So in here, I should get a link which says generate. This is actually a REST API client, which uses a trigger point here. So I can actually trigger the API right from Visual Studio, but somehow that's not giving me that option today. So in Postman, I will generate the same workload. In the meantime, while the Postman is coming up, you can help me by scanning this one QR code. This will generate random number of messages. I will also scan it from my mobile.
Sure.
So nothing will happen when you scan. It will just invoke that same endpoint. And if everything went fine, then when we look into the RabbitMQ UI, management UI, we should see certain number of messages generated. So I'm going to open the RabbitMQ UI here, or management UI in the browser. Okay, so I have Postman. Let me send a request via Postman as well to generate 5,000 messages. This one says status is okay. So 5,000 messages should have been sent to our RabbitMQ. And the management UI for RabbitMQ is available on this port 15672. I've done the port mapping or port forwarding for that. I should be able to see the status of the RabbitMQ. So here I'm connected to RabbitMQ UI. Okay, so there we are. So we can see the status of our RabbitMQ. So I have this queue where currently we have 24,946 messages pumped in by the scans that we did for that QR code, as well as those 5,000 messages that I generated from the Postman. And we see that there is one consumer. If I go down here, under the consumers, we can see one consumer is consuming, and it is consuming 75 messages because in the configuration of my consumer, I have set the batch size as 75, which means that every time the consumer picks up a number of messages, it's going to pick them in a batch. And currently it's picking 75 messages in one batch. And in order to simulate a workload, like a heavy workload while processing, I've also put a slight delay of 2 seconds between the processing of every message. So effectively, every second, there is like only every 2 seconds, there is one message being processed. Now, the way this is designed is, this is a kind of application or the consumer, which is stateless in nature. And it's also having, because of that batch size limitation, a very less amount of memory is required for running this. And I can replicate this. I can have multiple instances. As I increase the number of instances of my consumer, there would be more number of messages consumed. And this is where I want to introduce KEDA. Now, in the past, when we wanted to do scaling, we would rely on traditional metrics like the RAM usage or CPU usage. But since I've given this 75 as the batch size, my RAM usage or the CPU usage is always going to be within a limit. It's not going to cross that threshold. And if I keep this running, it will probably take quite a long time for me to consume all the messages. Instead of relying on the traditional metrics or of CPU or RAM, I want to rely on some external metrics, which in my case, I want to say, look at the RabbitMQ number of messages that needs to be processed, and based on that, dynamically scale the consumers. That is where KEDA is coming into the picture. KEDA has something called as autoscalers, which we can enable, and we can then go ahead and tell KEDA, within a range, you scale my resources. So let me just see where I am currently. Okay. I have a small PowerShell script which does this application or applying of the manifest files. I'm going to use that, and then I will walk you through what KEDA is doing internally. So let me first run that PowerShell script. Okay, fine. So in here, I have a PowerShell script which says deploy autoscaler. So what this will do is it will apply certain manifest files in my Kubernetes cluster. One which is related to creation of the secret, which is used to connect from the Kubernetes environment or Kubernetes cluster to the RabbitMQ broker. Then it creates something called as a scaled object or scale object. And then there is an authentication trigger. So let's switch to Visual Studio Code and look at this in a bit more detail. So under the KTest folder, I have these manifest files. The first one is creation of the secret, where we name this as KEDA RabbitMQ secret. And this is a secret to the host. Basically, we provide what is the protocol we are using to connect to RabbitMQ, what is the username and password, and we encode it and we store it as a Kubernetes secret. Then the next thing is the scale object, which is the most important part in the whole KEDA stuff. This is a custom resource definition, or what we call as CRD. When we install KEDA on our Kubernetes cluster, it creates certain objects which are required for functioning of KEDA, and it gives us one type of object called is the scaled object. It's a CRD, which we can use to define metadata related to our scaling needs. It has a scale target reference, which is the consumer deployment. So basically, I'm telling KEDA that using this scale object definition, you look at this RabbitMQ consumer deployment. There is a deployment in my cluster, which is named as RabbitMQ consumer deployment. You should poll this particular RabbitMQ every 60 seconds. And then you should keep the minimum replica count as 0 if there is no workload running or if there are no messages in the RabbitMQ to be processed. I can scale it down all the way to 0 and bring down the number of instances of this deployment to 0. And the maximum count that I want to have is 30. So within this range, every 60 seconds, KEDA will keep checking if there are messages onto this RabbitMQ. And then there is the trigger. Trigger defines what is the source of this information. So I'm saying the type of the trigger that I want to have is based on a RabbitMQ, and then I provide the metadata for that RabbitMQ. One thing is the name of the queue where those messages are populated. Second thing is the queue length. So this is the threshold which is checked using that polling interval. So every time, every 60 seconds, it will check how many messages are there to be processed. As long as there are more than 5 messages to be processed, I want to scale, or I want to use KEDA to scale my application. And then we also give authentication reference, which is the trigger, the secret that is used by the authentication trigger. So that is how we link our source of information or source of the scaling, which is RabbitMQ, to our target, which is the consumer deployment. Now let's go back to the RabbitMQ management UI, and we see a change very immediately. You can see the number of untracked messages has gone to 2,250 because there are 30 consumers running now. The scaling has already happened, and now, because of that range which we specified, saying 0 to 30, the KEDA realizes that there are 30 requirement for consumers to be run. We have enough number of messages to process, and it spins up those 30 consumers. It doesn't spin all this 30 in one go. It uses the progressive scaling approach where it will first scale to consumers, then it will see if 2 are enough. If 2 are not enough, it will go to 4, 4 to 8, 8 to 16, and likewise. When it is scaling down, same thing will happen. It won't scale down all the way from 30 to 0 in one shot. It will do it in a progressive manner. So that is another advantage of using something like KEDA, which can do this in an intelligent manner rather than just saying, let's go from 0 to 30 or 30 to 0. So with that, let's go back and see the slides. We already saw KEDA in action. Let's see how does KEDA do this behind the scenes. So for KEDA, there are two things which are really important. It doesn't create anything new as such, other than those custom resource definitions which are injected into the Kubernetes cluster. Internally, it still creates a horizontal pod autoscaler, but rather than creating it on the RAM or CPU usage, as I said, it will look at the scale object definition for the external trigger. So in our case, the external trigger is RabbitMQ, but there are various other built-in or out-of-box scalers which are supported by KEDA. And based on that trigger, it looks at the type of object which needs to be scaled. And it still works with the Kubernetes API. So again, we don't need any third-party software or anything else other than a valid Kubernetes cluster and KEDA installed on that. With just those two things, the source of the trigger or the event and the target object to be scaled, we can use KEDA along with the existing Kubernetes cluster to scale our resources. So this is what we saw in that scaled object, where we had the kind as the scaled object. We specified the target reference as the RabbitMQ deployment, and then the type of trigger as RabbitMQ, and then the metadata for how to connect or how to query the state of RabbitMQ. In terms of the features, what KEDA does is it helps us to do processing in event-driven manner. Now, if you see today's world, we have progressed quite a lot in terms of doing real-time processing. I remember back in, let's say, 15 years back when I was working for a big retail organization, we had things which were done in like batch mode, and a very simple thing which looks quite obvious nowadays, things like ordering food or getting a taxi ride and seeing the real-time how the driver is moving towards you or how much time it's taking for the food to come to you. It used to take quite a long time in the past. I remember when I was working for this retail organization, we had the system which used to do the online picking, and the time was like 2 weeks. The customers had to order 2 weeks in advance. If they had to do some change, they could do it maximum like 1 week. And after that, the order was locked. So that was the kind of processing power we had in the past, or the technologies that we had in the past. But over the last 10, 15 years, cloud has made things quite easy, and we can really have the scalability, agility, things like serverless. They make things very easy nowadays to build real-time systems or event-driven system. And we already saw in this demo that we can respond to the events quite quickly using something like KEDA. It also makes autoscaling very easy. We will see what are the different types of out-of-the-box scalers provided, but we don't have to write too much of code. And KEDA doesn't interfere with the existing Kubernetes objects. So tomorrow, if we decide that we don't need KEDA, we want to replace KEDA with some other better solution, we can just remove the KEDA-related objects from our Kubernetes cluster, and our existing deployments, our existing services, they will continue to work. I will show quickly what are the built-in scalers. It also supports the multiple workload types. We looked at deployments in this example, but even the Kubernetes jobs can be scaled using KEDA. It is vendor agnostic, and it can be deployed on multiple platforms. Anything that supports Kubernetes, we can deploy KEDA on that. And from a Microsoft Azure standpoint, it also has native support for Azure Functions. So before I move on, let's switch to the browser again and look at some of the KEDA scalers. So you can head over to keda.sh. That's the project site, and you can go through the information about the concepts that we talked about, how we deploy KEDA and the architecture. What I want to focus is the scalers. So as of today, there are 59 scalers out of the box, and this includes things like ActiveMQ, Apache Pulsar, Apache Kafka, AWS CloudWatch, there is AWS Kinesis, DynamoDB. So we can see that it is not just like messaging system. It can also connect to things like the blob storage. It can connect to Azure pipelines like a CI/CD tool. It can connect to databases like Cassandra or CouchDB. It can connect to monitoring tools like Datadog, Elasticsearch. It can connect to multiple clouds like AWS, Google Cloud, Azure, IBM MQ, for example. So different types of workloads are supported, and all this can be easily scaled by just specifying that metadata that we saw as part of the KEDA scaled object. So we looked at all these different autoscalers, and it really makes it easy for us to scale without managing the complex infrastructure. Think of doing this using your own custom scaler kind of thing. If, let's say, the horizontal pod autoscaler is not good enough for our requirement, and if we are to do something like this on our own, it would be quite complex to do this in terms of managing the infrastructure as well as the code from our side. But KEDA makes it really, really easy. And because of its serverless nature, or the way it can scale it back down to zero, we also get the cost benefit. We don't have to keep using the resources. We can really make it serverless by having scaled only when the need arises, and then scale back to 0. And the scaling up, it's again quite fast because we are using containers here and technologies which allow us to bring applications or pods very, very quickly. So in summary, what we saw so far is it's a very single purpose lightweight component. It doesn't have too many dependencies. Only thing it requires is a Kubernetes cluster with minimum 1.16 version. If you have a cluster below 1.16, it will not work. But in today's world, we are already at Kubernetes 1.25 version. So if you are running 1.16 or lower version cluster, then you're already almost out of date. It extends the Kubernetes by using these event-driven capabilities, and there is no overriding or duplication of existing functionalities. As we saw, the existing horizontal pod autoscaler or existing scalers, they can work as is. KEDA will just enhance that. It doesn't duplicate that capability. In terms of the event sources, where it can look at deployments, what we saw in this demo, but it can also scale the stateful sets, custom resources, or jobs. And it's flexible to run along with other Kubernetes frameworks or applications. And as I showed during the KEDA scalers, there are more than 50 autoscalers out of box. So if you want to learn more about KEDA and things like Docker, Kubernetes, you can refer to these sites. Play with Docker allows you to work with Docker in a browser. Same way, if you don't have a Kubernetes environment, you can use Play with Kubernetes to work with Kubernetes and try out different scenarios. There are some Linux Academy learning paths, which you can use to learn more about Cloud Native Foundation or certified Kubernetes applications, how we can build them on using the Kubernetes. If you want something very basic, I also recommend that you have a look at this wonderful documentation, which says 50 days from zero to hero with Kubernetes. It is done by the co-creator of Kubernetes, Brendan Burns, and he makes this bite-sized YouTube videos available where he talks about certain Kubernetes concepts. You can be watching this video while having your coffee or just taking a break. So quite useful in my opinion. And I've provided the references to KEDA and other things that I talked, like the horizontal pod autoscaler and cluster autoscaler. If you want more information on Azure Kubernetes Service, which I used, AKS, there is also a learning path on Microsoft Learn. And on my YouTube channel, I have done various videos regarding KEDA, AKS, Kubernetes, Docker in general. So you can also visit my YouTube channel to know more details. The source code for this demo is also published on GitHub. You can go to this URL PD TechFest and you will find the complete source code along with the documentation, how to configure, how to run the complete demo. So thank you for attending this. I've already published this slide deck to SlideShare and Speaker Deck. You can refer to that for future reference in case you need it. That's all from my side. Vishwas, if there are any questions, I'm happy to take them.
Sure. Like, let's just go on with the question that I had. Like, how can KEDA make an impact in the future of scalability, and how is this fraternity of engineering practices growing in the world today?
KEDA is quite useful in the serverless side of things. You see nowadays more and more people are trying to optimize the cost. One of the biggest factor why people are moving to cloud is to optimize cost, and we are past that stage where we just move VMs or we just move applications to cloud and we think that okay, we will be able to achieve the cost savings. Now people are looking at even when they are using things like the platform as service offering from cloud providers or different managed services, how they can optimize it further. It's not just good enough to have a Kubernetes-based deployment and you deploy the application to Kubernetes. We also try to make sure that we are using Kubernetes in the most optimal way, and even other things, like even if you're not using Kubernetes, you might be running normal serverless applications which are triggered based on some event. There also, you want to make sure that you are using the resources only for the duration when you need them, and you don't over provision them, or you don't keep them running when they are not required. And in that sense, KEDA really helps. You can scale down to zero, as I showed in the configuration. And if we wait for some time, we will be able to see that scaling down in action. So it can really help you to optimize the usage of your cloud resources by making sure that they are provisioned or they are really scaled only when they are required. And it can be a huge factor. In fact, there is a similar project from Red Hat, which is called as the Knative. And initially, it was thought of like a competitor to KEDA, but now I've heard that even Knative is going to integrate KEDA with their own features. So that is the kind of impact KEDA is having, and I definitely see that it is gaining broader adoption. If you use the Azure Container Apps, which is a new serverless offering from Microsoft that has a native integration with KEDA. So you don't require even installing KEDA on these kind of things. It's provided by default as part of the platform itself. Same thing for AKS. AKS has a plugin or extension which can be enabled. In this demo, I actually use KEDA via the Helm charts. I've installed KEDA using Helm charts, but I can also do the same using extension on Azure Kubernetes service. So I don't even have to install KEDA myself. The upgrades and patching, everything for that can be done by the cloud provider itself for me. So that's the kind of impact I see for KEDA coming in future.
Sure. I think thank you so much for such great insights. Hopefully we do a lot more sessions with respect to KEDA or else any other Kubernetes thing. Happy to learn from you. So we are ending the broadcast, folks. If you have any queries, questions, don't worry, don't hesitate. Reach back to me or else reach back to Nilesh so that we both can help you in starting your journey with KEDA. And also anything related to Kubernetes, do reach out to us. We are happy to help. Thank you so much, sir. And we are ending the broadcast.
Thank you.